let's take a look at another example. I'd like to find the limits of integration and set up the integral of f at xy over the region given. Again, in order to do this, I'm going to need to find the equations of each of the sides of the region. So I notice this side here is the line y equals 0. These other two are diagonals, so I'm going to need equations of lines. Now one of the two is pretty easy because it has the point 0, 0 and 3, 3. I could do all the work out, but hopefully you recognize it as the line y equals x. And then this one here, I'll need to find the equation. The point where we intersect the x-axis is 5, 0. So if I get the slope, that's going to give me 3 over negative 2. So that comes out even, so I could write it as a decimal, negative 1.5. Remember, again, don't write it as a decimal if it doesn't come out even. Now, in order to write the equation, I need y equals mx plus b, so y equals negative 1.5x plus b. Substitute in a point. I think I'll substitute in 5, 0. So 0 equals negative 1.5 times 5 plus b. So it looks like b is going to end up being 7.5. So this line is going to be y equals negative 1.5x plus 7.5. Now, again, I'm going to write out both versions. So the one that I'm going to do first is I'm going to do, let's see, we'll integrate f at xy. Let's write that down. I'm going to integrate first dx dy. Okay, and you'll see why in a minute. But I'm going to integrate f at xy dx dy first. So my outer limits will be my y limits. So again, those are numbers. So the bottom y is y equals 0. The top y is y equals 3. Now, to do the inner limits, I need to do from x equals to x equals, which means I need each of those equations written in the form x equals. Well, y equals x is pretty easy to write as x equals. That's going to be x equals y. If I have y equals, I'm going to rewrite this as a fraction, negative 3 halves x plus, and let's see, 7 and a half is 15 halves. So if I want to solve that for x, multiply everybody by 2. So that gives me 2y is negative 3x plus 15. And if I do a little x solving, I'm going to end up getting x equals negative 2y plus 15, all divided by 3. Again, I flopped the negative 3x to the left-hand side, brought the 2y to the other side, and divide both sides by 3. So now as I look at this, to do the x's, I go left to right. So the left side is x equals y, and the right side is negative 2/3 y plus 5 if I divide that out. So again, if I just neaten it a little bit, I'll go from 0 to 3 on the y's. I'll go from y to negative 2/3 y plus 5, and then f at xy dx dy. Now, if I want to do the integral the opposite way, you'll notice that something kind of strange happens. The x's will be kind of normal. We'll go from 0 to 5. That'll be okay. That'll be the outer integral. But notice when I do the y's, when I go bottom to top, remembering those have to be functions. For part of the problem, the upper function is the positive slope curve, and for the other part, it's the negative slope curve. When that happens, when your inner integral uses two separate sets of functions, you have to break the problem up into two integrals. So that's what I have to do here. So f at xy, and it's going to be dy dx, and then plus f at xy dy dx. Now again, the integrals will be x's on the outside, so those will be numbers. And so notice if I break this up into two pieces, the x's, which are on the outside, will go 0 up to 3 first, and then on the second piece they'll go 3 to 5. The y's will go 0 up to, and remember this has to involve only x's, so now we use our regular function, negative 1.5x, oops, excuse me, that's not the right one, is it? Erase that. 0 up to the first one will be 0 up to x, because that's y equals x. And then the second one, the y bottom is 0, and the function is negative 1.5x plus 7.5. Again, remember the inner integral must involve only numbers and x's. That's a little bit tricky, and you might want to take some time on your own to try to figure it out and try the example again. It is one of the harder ones that we'll do in this set of notes.